So we've definitely taken a little bit of a deep dive when it comes to these batteries that are pre-made and meant for a certain purpose. But what if you wanted something more and didn't necessarily want to go just based on what the manufacturer said you could have? What if you wanted to build something yourself by just taking some raw cells, a BMS, maybe an inverter, and throwing it all in a box? That sounds like a pretty good idea. Let's do that today. So what you see in front of you here is a series of renditions of batteries that I've built over the years. Like I said in my first EcoFlow story, I had a backup that did work for our fridge, and that's what you see right here. This rigid toolbox contains a backup as well as an inverter that allowed me to run my fridge for about 13 hours, and it's actually gone through a couple of renditions itself. So I'd like to first go through the history of what this has been, and then we're gonna look to upgrade it today by implementing some safer tech, some bigger batteries to give me a little bit more runtime in case the inevitable happens. And we're doing that all thanks to today's video sponsors,
Vatrer batteries for sending over these 3 100 amp hour 12 volt batteries, and Haistronica for sending over a ton of connectors as well as tools that we'll need to make this project work.
I agreed to feature Vatr's 100 amp hour 12 volt battery because of the reputation they've built in the online community. A lot of different people who have better equipment than I do, at least at this time, hopefully we're going to be upgrading here soon, have been able to put these really through their paces and ensure that they're getting the proper amount of output and that the batteries are built to a certain standard. Now, today I'm not going to be taking these batteries apart to verify what's inside of them. If you want to watch a video like that, I certainly suggest going and checking out Will Prowse's channel. He definitely has, again, the equipment and a little bit of additional knowledge to know how to take these apart safely and verify what is working within them. For me today, really just wanted to go ahead and get these into a pack and show you how you can build your own solar system without having to go through one of these other manufacturers, and have some faith that not only is it going to last a very long time, but also that if anything goes wrong, you'll be able to fix it yourself. The question that I want to answer today is, can you build your own battery for the same price or cheaper than what you can go out and buy an EcoFlow unit for? So let's go ahead and dive in, see what we can find here, and see if we can get this battery built on a budget. So the first rendition of this rigid toolbox actually came about because I got a good deal on some used e-bike batteries. These packages were 10S cells, meaning that they put out approximately 32 to 42 volts, depending on their current state of charge. And the company that these belonged to went out of business and had a ton of stock left over and ended up selling them on. Now these required some wiring inside of them to trick the BMS into giving us an actual output on the output leads. But I was able to go ahead and get both inputs and outputs on these XT60s. And combining all of these together, I was able to hook it into a 1500 watt pure sine wave inverter that I have right here. And this is what has powered my fridge, air conditioners, or other small appliances when we've been without power. I originally built this unit because we were going to be having some electrical work done on our house, and that was going to put our electricity out for about 12 hours. I didn't want to, again, lose anything in the fridge, wanted to make sure that we didn't have any issues with spoilage, so I went ahead and put this system together, and essentially it just hung out inside of this toolbox until I needed it. Now I did end up eventually upgrading this system, and I stopped using the e-bike batteries. What's in here now is a set of cells that I actually put together myself using some brand new 18650 cells. So this is again a 10S pack of cells that was built using 18650 batteries that were brand new. These were never used, never had been spot welded on before, so there wasn't a recovery effort. It was really just making sure that I had something that would be nice and stable. They've actually only gone through about 3 charge cycles at this point, so I'm definitely going to reuse these in another way. But ultimately the issue that came down with these is that the capacity just simply wasn't there. So instead of going this route and just adding more 18650s, we're going to go ahead and bypass this completely, and we're going to move into the realm of lithium iron phosphate batteries. Now I was originally hoping to be able to reuse my original toolbox. That rigid toolbox has actually worked pretty well, but 3 of these just barely will not fit in there. It's basically about a ½ an inch too small, and because of that, there's really no way for me to fit these in there along with any of the other components. Now that's why I stuck with a 36 volt system, but why might you look into a 36 volt system? Now we could very easily wire these batteries up all in a parallel configuration, connecting all the negatives and all the positives together straight out into an inverter, and that would produce 12 volts of power. In this case, because they're fully charged, closer to 14. The problem that you run into with a 12 volt system ultimately comes down to physics. Voltage times amperage equals your watt. In this case, I know that I'm going to need about 1500 watts to start up my refrigerator at home. So my baseline, my constant amount that I can get out of my inverter is 1500 watts. Now, if I'm doing that with a 12 volt system, we need to take that 1500 watts, and in this case, to find out how many amps we're going to be pushing through this battery, we need to take that 1500 watt and we need to divide it by the 12.8 volts, which is the nominal voltage of this battery pack. That would mean that without factoring in any efficiency losses at all, we would be requesting approximately 125 amps out of this battery pack. Now that would be safe for the batteries themselves. These can put out 100 amps each as a continuous amount, and because of that, we've got 300 amps worth of power here that we could theoretically put out at 12 volt. The problem that you run into there, though, is going to be the wire size. Now, as we discussed in a previous video, the size of the wire, the gauge, the thickness of the wire is going to be determined based on how many amps you need to put through that wire. Voltage doesn't really matter in case. We can put thousands and thousands of volts through a relatively small wire as long as the current, the amperage, isn't that high. Once you start adding more and more amperage into an undersized wire, you start to build up heat, and that heat could potentially combust. It could simply melt the coating off of your wires, which would cause them to then potentially cross, causing even more issues. And again, you're looking at a compounding issue there. So to be able to push through 125 amps out of the system, we would need to wire these battery to battery as well as battery to the inverter with 2 gauge wire. And that's a pretty beefy size wire. Now, if we do simply reverse one of these cells and instead stack the cells in a series configuration, then instead of simply multiplying the amperage that we can put out, we're actually going to be multiplying the voltage that we can put. So our 12 volt battery turns into a 24 volt battery when we wire 2 of them in that configuration, and a 36 volt battery when we wire 3 of them in that configuration. Now, when we're still talking about that same 1500 watts that we need to pull out of our inverter, the 1500 divided by the 36 volts means that we only need to put out a little over 40 amps in this case, meaning that we can go with a much smaller gauge wire. We're gonna have less loss as far as heat goes. Our inverter will be able to work more efficiently, and in most cases can be a little bit smaller because it's able to work with smaller wire gauges and smaller traces inside of it as well. Now, I personally don't suggest going a 36 volt route. 36 volt is actually very hard to find complementary components for. Most systems that are made these days are going to be either 24 or more often now we're seeing the 48 volt system. Most people are still going to try and stay under that 50 volt DC just because that's where kind of your safety threshold comes into play, where you don't have to worry about touching the battery terminals and getting a shock. So 48 volts really seems to be the most popular option these days. Now, as I said before, I'm not a review channel, but I still want to verify that what I'm getting and what I'm offering up to my subscribers are going to be good products. So I did already do some testing on these devices. So I'm currently using a DC load that only allows me to drain these at approximately 100 watts. I've gotten up to about 150, and then sometimes this device overheats and will end up cutting out. But that means that I'm only draining these batteries at approximately 1/10 of the actual amperage they would normally be putting out. That matters because the higher of a C rate or charge rate that you push to a battery will affect the capacity that shows up on your testing equipment. The reason why, again, comes down to that heat. As you push more and more amps through a battery, through wires, through a ton of different things, it's going to generate heat. And heat is a byproduct. Heat is something you don't want. Anytime you have heat coming out of a battery, that means that the battery is wasting some of its energy in that heat, dissipating some of that energy just out into the air. So this will only pull a 0.1 C rate on these batteries, so they're gonna test high on this no matter really what I do. In this case, I did get over 100 amp hours. In fact, on this battery, I don't believe, based on the charger that I'm currently using, it was even at its potential maximum charge. They say that these can go up to 14.6 volts, but I pulled over 107 amp hours out of this battery, no problem whatsoever. So again, I believe that these are definitely what they claim to be based on some of the other reviews that I've seen, and if you want a review, check
check out Will Prowse. Most of you are already subscribed to him based on what I see in my statistics anyway. He does have some good reviews on these Vatrer batteries, as well as some comparisons to other batteries. So we've discussed the importance of making sure that you're using the right size wire for your build. And that, of course, is going to come down to, again, the voltage and the amperage that you're expecting to pull out of it, and the wattage of your inverter itself. So the question now becomes, why jumper cable? So as anyone who lives in America knows at this point, we're still dealing with this tariff thing. What I have found, at least in month past, I don't know if this is still going to be the same, but consumer goods and commodity goods like jumper cables generally don't fluctuate in price as quickly as the pure copper wire. I was able to go and find the copper wire that I needed from a couple of industrial and scientific distributors, but their prices fluctuate daily. They go based on a market price. Now, the wire itself, as long as you're getting what you expect, the copper clad aluminum or the pure copper, is really going to be the same. Your sheathing on the outside is going to be slightly different from make to make, but generally these are going to be made in a way that they are going to be safe to use up to their rated capacities. So the insulation itself, I don't need to be anything special. I don't really need silicone wires for something that, again, is going to be stationary and only used in emergency backup situations. So these wires will work perfectly for my purposes. I get a very long length of good gauge wire for a reasonable price. Now, I mentioned before there's two things that I look for when it comes to accepting a product from a brand. The second thing that I usually look for is whether or not I've ever used that company's products in the past. Now, I've had this little ferrule crimping tool here for about 4 or 5 years. Worked pretty flawlessly. I mean, I'll be honest, these things are relatively well known by this point. It's not something where a manufacturer is really changing the game on them. These aren't any better than the other products, but they were the cheapest at the time when I was looking. They've never failed. They came along with a lot of different ferrules, but something that I used on a previous project many years ago and still had it. Now, when haisstronicaheatgun reached out and said, hey, we like what you're doing on your channel, would you like to use some of our tools? I went back into my toolbox, said, I already am, sure, send me some. And they were more than happy to go ahead. They sent me their catalog. They said, hey, what do you need? And I told them, hey, I've got a project coming up soon, and I'm gonna need some really big lugs and way to crimp them. For full transparency here, these tools are nothing special. Haisstronicaheatgun hasn't gone and reimagined the game. They haven't really put anything new into this type of friction crimper that other manufacturers haven't, but their prices are very competitive, and their tools are, in my experience at least, good quality. Good enough for what I need to use them for, and for the projects that we see around here. So I'm happy to go ahead and show off their products and use them. I don't really have to say anything favorable. They don't get any options to they don't get any options or opportunity to view this video before it goes out, just like Vatrer doesn't. But again, these are products that I got from them for free, and the links will be down in the description if you need some good quality products as well. What we're going to be doing here today is making up our own wire. The first step in building our battery pack here is that we need to ensure that all of our batteries are actually balanced between themselves. When we put these into a serial configuration where the batteries are adding their voltages together instead of keeping the same voltage across, they're not going to be able to self-balance in that configuration. So we need to make sure that we're at a good starting off point and that we're able to get these all at exactly the same voltage before we wire them up in series. That way, as they drain, as they charge and discharge, the balance should be relatively close among them. Now, these are all going to be inside of our Bauer toolbox, so not a lot of space. I don't need to go and make 6-foot cables or anything like that, but I'm going to make sure to make these about 2 feet long just to give us that extra length that we are going to need. So we're going to go ahead and snap them off. You do want to make sure that you've got a good set of snips for this. Again, thank you Haisstronicaheatgun for the snips there. I had never used one of these before, and when I was making this video, started looking through what was necessary. We actually went to Will Prowse's channel, looked at his recommendations, and he had one of these. This thing is awesome. What it allows you to do is put your wire directly in here. You go ahead and just simply spin it around a couple of times to cut that sheathing, and then you slide it out. What that does is puts a cut right down the center of the sheath, so you can then just pull it right off. No fuss, no muss. You don't got to use your teeth and get in there and really grind on it, and you're not sitting there with a razor blade trying to make sure that you only cut just deep enough. And then what I'm going to do is look for my copper terminal lugs that are the right size for this wire. Again, I'm working with 6-gauge wire here, so I'm going to look for the ones that are labeled as 6-gauge. You definitely want to make sure that you don't have any extra wire showing here, and we're even going to put over some heat shrink here in just a moment so that we can protect this entirely and make sure that it doesn't have any risk of, as it's connected to the battery, potentially shorting running on anything else. Now, once you have this on like that, we have here our 6-gauge wire. I need to go ahead and open up the jaws of my tool and change this over to a 6-gauge configuration. All right, so for our crimpers right here, what we're going to need to do to get this down to the right size is go ahead and simply change the jaws. Now, if we push in on this little lever here, it releases the jaw so I can then spin. All I got to do is go to the right size. In this case, we are looking at 6-gauge wire. I need to do that on both sides here. 6. And now this is appropriately sized for the type of wire that we are currently. Thanks to Haistronica, they sent me out a nice new heat gun as well. All right, so I've got my cables made up. We've got our batteries laid out here. Again, all negative on one side, all positive on the other. But what we're going to do now is just simply go ahead and connect our negative to negative, positive to positives. Going to have 2 on the middle one here. All right, so we now have the batteries connected. When I first connected them together, they were pulling about 10 amps between the different batteries here. Now that they've had a chance to settle in for a couple of seconds, I'm getting about 1.6 amps coming from this battery into this one, and about 1 amp coming into this battery, from this battery into this one. So we'll leave these in this configuration for a couple of hours. I'll come back, I'll verify with my DC meter that I don't have any current going through them, and then verify that all of the cell voltages are exactly the same. That will tell me that all of these batteries are then balanced and able to be put into that 36 volt series pack without having to worry about one of them, at least right away, significantly coming out of balance and potentially putting additional load on the other two.
All right, so we've got the batteries already set up and ready to go. Also have another outfit change if you haven't noticed. Luckily, nose is no longer giving me trouble. We'll see if we can get through this time. So the layout for how I'm going to put the batteries in here is still a little up in the air. I've found a configuration that works, and you may notice that the inside of my box has some chicken pox going on here. That's because I originally had grand ambitions of trying to 3D scan this, which I did successfully, and I'll show an image of the 3D scan somewhere around here. So I 3D scanned this in, and my ambition was to go ahead and try and lay everything out in the box, make a nifty visual presentation of what it was going to look like, and realized that I was a little bit beyond my depth when it came to that, and it wasn't coming out how I wanted it to. So I do have a layout that works relatively well in the box. My concern, though, is whether or not I'm going to be able to fit everything in here that I want. So again, on top of the batteries and the inverter, we're also going to have a 12 volt DC buck converter to take the 36 volts down to a 12 volt signal that I can then use for my DC appliances. It will also have AC outputs on the outside of the box. I again don't want anything to I don't want to have to open this up to be able to plug things into it and things of that nature. I plan on having an external switch so that I can just flick it and the power for the inverter will turn on automatically. And then I want to have all of my charging ports on the outside of the box as well. Last but not least, I do have a solar charge converter that we're going to be installing in here, and again, a port on the outside of the box that eventually I'll be able to plug some solar panels into. It's not a super fancy one, but we'll take a look at that here in a sec. Now, the one advantage that I have is that the lid for this box is actually relatively thick. So I've already started working on some of my layout ideas for this guy, and my idea is that this top section here where it's nice and flat, that's where I want to go ahead and put my control panel as well as my DC outputs. Those I have a panel for that the DC outputs came with that will fit in here nicely. Just gonna have to do a little bit of dremeling there. For the other components, on the inside of the box, I've already started to tear into this as well. So you notice that there's a section of this kind of mesh grid that's been cut out. And this section here is for the solar charge converter. And then I have a section here where I've cut a small piece out for my 36 volt to 12 volt DC buck converter. So my hope is to go ahead and wire that in here. I'm gonna run those wires right over to here. This is that panel that we were looking at a second ago from the top where our DC ports will be, as well as the switch to turn on and off all of the DC access. And hopefully this is all gonna fit. I'm sitting a little bit proud right now of the top lip here, and the box is very full once I get the batteries in here. You'll see that in just a second. So I'm not 100% sure this is gonna work how I want it to yet, but we've got some room to move still, and I think that we're gonna be able to make this happen. So let me go ahead and grab the batteries, and I wanna show you the configuration that I found that worked best in this box. Now, to make this configuration work, I did have to cut out some of the ribbing on the inside of the box as well. It's a little bit tedious. This is some very, very hard plastic. It's not ABS, it's some kind of a fiber fill plastic. I don't know if this will come out on camera, but you can kind of see it's that real industrial strength stuff that they kind of make these toolboxes out of. So I had to cut some out to allow one of these batteries to sit in here in the orientation that I'm about to show. Now, my idea for this was to go ahead and keep our terminals separate so that we don't have any possibility, even if this does get jostled around, say I'm moving in a couple of years and I go to throw it in a moving truck, I don't want any possibility of these terminals crossing and touching each other. So to avoid these from touching and possibly shorting out, I'm going to have one of them with the terminals towards the bottom, one of them with the terminals towards the top, and that should avoid any potential shorts, even if this is moved and jostled around a large amount. Now, this just barely fits in here, right behind this first ridge here, and that's exactly what I want to see, because that should give us just enough space. Back it up here, actually. That should give us just enough space to go ahead and slot the other battery. This one goes in similar, but again, I want the terminals facing the opposite direction. So now that we've got two batteries down in the bottom of this toolbox here, also fits in just like the other two, but we've got a little bit more space up top here once we slot this third guy in. And in fact, if I recall correctly, I wanted to do it this way, because then what that allows us to do is quite comfortably put our inverter in just between the wall and this battery. And that is something I definitely want to try and secure a little bit better than this, of course. It is just kind of floating in there right now, but it's held in by that battery and it's not going anywhere. Once I get the lid on this, it really kind of closes this in tight and makes sure that it's not going to have any possibility of moving around. Now, I do want to fill in some of these gaps here with some foam that I have, the packaging foam that actually came with these batteries on top of some others, and that will give me some comfort knowing that it's not going to be jostling around a bunch as I do transport it, like between the warehouse and home. Now, we're going to go relatively quick on this because I've already started editing this video and I know how long it is already, and I know you guys don't like when I go too long on the videos, so we're going to try and get through this next part as far as the actual build process pretty quickly. For a solar charge converter, I have an eco-worthy solar charge converter, frankly just because it was very cheap. I did have previously, when I was planning this build many moons ago, I did pick up one of these MPT 7210A chargers, and people used to swear by these things. It always just seemed really cheap to me. It's made by a company called Junetech. It's called an MPPT charger, but it's actually inside of here is just a buck boost charger. I wanted to go with something that was a little bit slightly more name brand maybe, just so you guys wouldn't give me quite as much grief. So I did go ahead and buy an eco-worthy one. It actually feels a little bit lighter, which is weird because it has cables and everything coming off of it, but we're gonna stick with the brand that people at least know. This does have one thing going for it, and that's that it can be set to pretty much any voltage. So like I said before, finding components that work with a 36 volt system is very difficult. This one will work from anywhere from 12 volts all the way up to 72 volt. You do have to kind of do a little bit of trickery with the programming to get that part to work though. My concern for right now though is whether or not this is actually even going to work in the spot that I currently have cut out for it. As I put it in here, it does sit just ever so slightly proud of the lid. I think that we're going to be compensated by the inverter just being slightly off there, but to verify that I need to get some tape. That duct tape will hold well enough. I've got it duct taped in there about as horribly as you could possibly do, but it should at least stay the right side up for me. Does this actually go on and will it load? Yep, it did. Beautiful. All right, so we've got our solar charge converter. We've got a spot for it. Now we can start screwing stuff in. That's great news. Solar charge converter goes right there. I've already got my adapters necessary to adapt it into the device itself, into the battery bank rather itself. All right, and we're just going straight through on these. Nothing fancy here. Now for the 12 volt side, I went ahead and picked this guy up. This is just a DC to DC converter. Takes anything from 17 to 65 volts and steps it down to 12 volts, 10 amps. So up to 120 watts off of this should be able to do a good amount on DC, get us some USB-C charging at least, and stuff like that. All right, so now that we've got these laid out, it's just a matter of getting our bolt into the holes. How are you guys doing today? Doing well? Sitting here doing some stuff with my thumb, you know, no big deal. Go crazy and start talking. I know you've got all that done. The next part that I wanted to go ahead and tackle was gonna be opening up this top section, which is going to be specifically for our 12 volt DC jack, as well as I've got a 12 volt DC monitor, a little switch to turn on and off our 12 volt, and last but not least, some USB port to provide charging capability there as well. And I've already laid out where I want this on the top of this lid, so now really all I've got to do is go ahead and drill out the areas where I need to go ahead and mount those. All right, so now we've got 4 holes in the top of our lid here. should hopefully be perfectly spaced out for our little plate there, what they seem to be. We'll see, we'll see. All right, perfect. So now that I've got those 3 pieces in, the last piece is just going to be a simple toggle switch here, and that's just going to allow me to turn on and off the 12 volt going to these devices. We'll pop this guy right into its home, located away. And then this kit came with all of its wiring pre-assembled, so really all I have to do is just push some pieces onto other pieces here, and it couldn't be simpler. So now that is ready to wire into my 12 volt outlet and be all set. So now we've got our DC outputs taken care of. Now we need to worry about our AC output. So back over at the box here, we've got our batteries on this side. Don't necessarily want to put any extra wiring over here that I'm going to need to worry about. But on this side, this is where our AC outlets or outputs come out. And if I take our plugs here, plug one in there and one in here. Hopefully we've got enough space in here. These plugs should have a little bit of movement room inside or allowed. So let's see here. Oh, that's not good. The plugs that I got are a little too beefy. I got some 20 amp plugs because they were the same price as the 15 amps, and I thought, that'll be fine. But because these wires are so much larger, it actually doesn't. All right, back to the drawing board on those. So for now, it looks like we're unfortunately gonna have to lift the lid here if we need to get to at least certain components. We will come back to that at a later date. Unfortunately, that just means it's not gonna be completely finished by the time this video is done. No worries though, we're good, we're good, we're good. So our AC ports aren't gonna work. I need to go ahead and revisit that and try and find some. I don't think I'm gonna get them in time to get this video out. So I'm currently recording this Wednesday night, and this has to be out by Friday night. So let's go ahead and just start working on the wiring. How about that?
Editor4 here. So some of you who are more observant may notice that in these next couple clips, I no longer have my jacket on, and my microphone was attached to my jacket. So didn't get any audio, doesn't last more than a few minutes here, so we'll just do a little bit of voiceover. At this point, we're simply wiring the batteries in that 36 volt series configuration. So what I'm doing here is wiring one battery's positive to the next battery's negative. We will then wire that battery's positive to the third battery's negative, and our main positive and main negative will come out of the 2 terminals that are kind of still left open. For this, we luckily only need a total of 4 wires. The red and black wires in this case are not going to make a lot of sense, with the exception of the main positive and negative coming off. I made sure to keep those color coordinated. Next part, not super interesting, so we're going to skip ahead a little bit. So now we've got 2 of the batteries wired together, and our main negative and positive there should be carrying 24 volts, or more realistically, 26 volts based on the current state of charge. At this point, it's just a matter of getting the battery seated down and make sure that, again, these terminals are separated. You'll see that I have the shipping terminal caps on there. That's a good thing to continue to use, just to make sure that nothing does short out if it does inadvertently touch something metal down there. Now that we've got 2 batteries in the bottom here completely wired up, it's time to go ahead and throw some foam in. Again, this is really just meant to make sure that the batteries aren't sloshing around in there and make sure that they've got something rigid to back up against. Because these aren't raw cells, we don't need to worry about putting pressure on the outside of the batteries, as they already have that component covered inside of the internal structure. So I'm going ahead and cutting up some foam here just to fit within the different crevices to, again, make sure that these batteries aren't able to move around as they are inside of this box. Now, before any of you ask, I did check. This foam is a little shiny, so I wanted to make sure that it was non-conductive, and it in fact is. There was no conductivity coming through this when I checked it with my multimeter. And here we're putting on our final lug, which is going to be for our main negative. Again, the positive I still have kind of just dangling off to the side at the bottom of the frame here, but I do have it covered up with some non-conductive tape just to make sure that it doesn't accidentally cross. Again, while these batteries do have protection circuitry built into them, from what I've heard from reviewers that have done a more in-depth test, the protection circuitry is temperature-based. It's not current-based. So even though these do have protection, which will eventually trip, putting these cables together could cause a very large amount of current to go through them, upwards of multiple hundreds of amps, and it could take up to 30 seconds for the batteries to actually cut off. Definitely don't want that happening. So because of that, I've gone ahead and protected and isolated that. Now we're laying the final battery in its resting place here, making sure that none of the wires are pinched underneath it, because really we're at very tight tolerances on this box and can't afford that extra 1/4 inch. At this point, it's really just a matter of getting the inverter in here and making sure everything is secure with some additional bits of foam, and then we'll be able to see what this box looks like all assembled. And just test fitting to make sure that the inverter does sit in here. Before we wire this together, we are going to need to make sure that we have all of our 12-volt accessories wired in as well. So I won't be plugging it in quite yet. We're going to head back over to the workbench here in just a moment and get all of our 12-volt components wired together.
Well, that's fun. You guys might have seen what I just did there, but you probably didn't hear any of it because I took my jacket off earlier and realized that my mic was on my jacket, which was way over there. So maybe we got some voiceover in that. Maybe you just won't see it. Honestly, don't know. Wasn't very much exciting going on there. What we did at this point is we went ahead and wired in our DC charge port into the lid with our eco-worthy DC charge controller. And now at this point, the only other thing that I really need to do is worry about this 12-volt system and how I'm going to get power to and from it. So the first thing that I'm going to do is wire our 12-volt output directly into our 12-volt components. So again, for that, I'm going to be using heat shrink connectors. So with our heat shrink connectors, again, I'm just putting my positive to my positive, my negative to my negative. These wires are close enough in the same size that they should fit in the same kind of connector here. All right, so here's what I did while my mic wasn't working earlier and what you guys might not have seen. So we've got our connector here for our DC input. This is going to be our 12-volt DC system that we're looking at right here. So the first thing that's going to shrink is going to be that glue and the heat shrink itself. That'll kind of hold the wires together as the solder then has a chance to shrink over them. Trying to get a way that I can show you guys without toasting my fingers, but it's unfortunately not working out that way for us. So now we've got our 12-volt wired in as far as the output side. Now we just need to go ahead and wire these into the input, which is actually just going to be directly into our battery. All right, so let's go ahead and get this one heated on. I can tell the glue has already melted and filled in its spots, so now we're just waiting on that solder to get a little bit more melty. All right, so that's our positive DC sides. Ooh, that's hot still. All nice and connected. Now we just got to worry about our last connector here, which is our negative. And then we will be good to go on the wiring on this side. Then we just have to wire everything into the actual battery and inverter. All right, perfect. So the only other thing we need here is we do need a fuse for our DC 12 volt, and then we will be good to go on that. But we have at this point the lid taken care of. So back down here on the floor level, not much has changed down here. We've got our batteries in, we've got our negative and positive already set to go. The next thing that we're going to do is be wiring in the inverter. I'm also going to grab all of our DC componentry and just kind of lay it on the back here. That way I'm ready to go with it because it's going to be plugged right into here as well. So how this works, we can plug in either the battery or we could plug in the DC first. I want to plug the battery in first just so it has the best connection directly to the inverter here. So for that, we've got our, again, positive and negatives here. I've got the positive already covered, so I'm actually going to wire the negative up first just to get it out of the way. It's going to go right on there. And we're also going to have our DC from the top right on there as well. And so those are going to go onto the negative terminal here. Hopefully this DC one is big enough. I didn't think about that. Oh my God, it's not serious. Why? Why can't you just be the right size? All right, take two on that. I had to put on some new ends here. Again, thanks Haistronica for sending over all of the ends and the connectors that I needed for this project, even the ones I didn't know that I needed. So let's try this one more time. So we're gonna go ahead again, we're gonna take the main negative from the battery, go ahead and pop it onto this negative terminal. We're then gonna pop our negative from our 12-volt system from the top, put our washer on here. Now this type of terminal here on this particular unit is just a hand tighten type terminal. Don't necessarily like those. I'd like something that I could torque down just to be sure that it is 100% secure, but that's what we have to work with this particular unit. I got this one because back in the day they were known as being one of the better units, the reliable type
and it has worked really well for me. The company that it's made by sells inverters under a bunch of different brand names, and I do have another inverter from them that I'm going to be using for a different project here coming up soon. All right, so we've got those in there. Pretty well secured down. So now we should, in theory, if I turn on the inverter here, we should have power, AC power coming out of this system now. I am showing 40.1 volts total, 40.2 now, and we do have 122 volts coming out of our inverter. The other things to check here are going to be things like this charge controller, which I don't think are going to power up until we actually get juice into the other side of it. So I will need to go in and make some modifications to how it is set up so that it can work with the 36 volt system. So let's go ahead and work on just getting all this put back together. So we're going to pop our inverter down into the box here. We will then pop the lid of the box on. And with any luck, we should be able to seal this guy up without having anything pinch. And there we have it. We're a little bowed on the front here, but it does fit under the lip still. All right, so that does it, guys. So I've got my box now set up with all of our DC outputs on the top here, DC input. If I ever need to use this in an emergency situation, all I gotta do is pop this top here, and then I'm able to get into all of my wiring, as well as my inverter to run my AC powered appliances. Last thing I want to check here is I do want to go ahead and get a fuse in here, just verify that my 12 volt system is working properly and that I don't have any issues there. So this guy uses just a standard automotive tile fuse. They gave me some 30 amp fuses to go along with this power adapter. All right, perfect. And we do see we've got the 12.1 volts DC coming out of this guy here. All right, so that does it. We now have our Bauer battery box. It still does roll a little, at least. It doesn't like to, I would say. It's definitely put on some weight. But if I pull my handle up here, yeah, there we go. Not bad. So this guy can still be ported around, moved around as needed, has tons of storage capacity, more than any of the other battery banks that I have, including the Delta Pros that I've been working with. So yeah, great little unit here, very reliable power, should charge up thousands and thousands of times before I even need to worry about replacing it. And so that is how you DIY a system. The Bauer box itself costs 60 bucks. I got it on sale. They're usually, I think, about 80 bucks. We already know that the cable that I used on this, and I used a very small amount of the cable that I had, cost $20 total. So we're up to about 80 there. The batteries themselves normally would cost around $250 a piece. Right now they're on sale for about $160 total, with some of the other miscellaneous items that I bought, like some of the bolts, the plugs, the different connectors that I got. A lot of it I didn't end up using just because of either space constraints or I was just a little overzealous when I went and I started ordering. But total, I would say that I've got about
660
into this battery box. And I would defy any of you to go online and try and find a pre-made solution that's going to give you the same thing for around
700 bucks.
Don't think it exists. Most everything out there is going to be either half the capacity, or it's just simply not going to be a quality unit. It's going to be something that's going to end up dying on you in a couple of years, like unfortunately some of the products we've seen on this channel. And yeah, so would I do this again? Absolutely. Even if it was coming out of my own money, I'd say that this is going to be a much better deal than going and trying to buy used power stations or repairing them, or trying to buy something brand new. This also gives me the opportunity to expand it later on down the line. So if I wanted to go up to maybe double the capacity, all I've got to do is buy 3 more batteries and do a little bit of wiring. Probably another box as well, because I'm not going to fit much more inside of this one. But for its capacity, for its size, for its functionality, I'd say that this thing's a pretty good win. So again, thank you so much to Vatrer for sponsoring this build and giving me those batteries. Again, no money exchanged hands. I don't have any reason to lie about the quality of the product that I got because, again, for my purposes, these things are going to work perfect. I will have a new testing setup coming out very soon. I'm working with a couple of partners to try and get that all pieced together. So again, thanks so much for joining. Please feel free to hit that subscribe button. Hit the like, it helps more than you could think. And then I'll be back with you guys actually early next week in this case, because we've got a framework giveaway coming up here real soon. More than likely the following day, I'm going to do a live session, a live stream. I'll announce it a couple of days early, but the live stream will be where we pick our winner. So yeah, I'll have a random number generator. I've already started tallying up all of the entries. We are currently at 1,027 entries. So decent number, but not bad odds. So if you still, you've still got plenty of time, go in. You've got until the 17th to go in and get that entry in, and we'll do that live drawing. So thanks so much, guys, for sticking around. I'm going to go ahead and get home. It is, as I look at my watch, it isn't a watch, very late, and I've got work in the morning. So, but yeah, thanks, guys.